Okay, like I said, those 2 toolkit entries that we put in your toolkits, they're on your notes for you. I have 8 examples for you. Most of them go really quick. I don't want to hear the moaning and the groaning. Yeah. They go very quickly. Most of them do. Like I said, you can make these really hard, or you can make them really easy. For the first one, if I want to simplify 4 to the negative third power, our main goal is to eliminate any negative exponents. Now, just as a reminder, if I have a negative exponent and I want to make it positive, if you flip it over the fraction bar, it flips the sign. So if I want to make that negative 3 a positive 3, I'm going to flip it to the denominator of the fraction. Now, if you flip a number to the denominator and there's nothing left in the numerator, make sure you put a 1 up there, because if you leave it empty, it looks like it's not even a fraction. So now I have 1 over 4 to the third, and if I evaluate 4 to the third, what is 1 times 1, or sorry, 4 times 4 times 4? 64. So 4 to the negative third power is the same thing as 1 over 64, because I can't erase. Okay, most of these, there's going to be a couple different ways that you can go about solving these. Most of the time, there's a couple ways you can go about solving these, and I'll do my best to show you both ways, and then you can decide what way you want to continue to solve these problems. For this next one, if I have 5 to the 7th times 5 to the negative 9th. We have a bunch of exponent rules, and a bunch of them I can apply to this one. So let's say I want to make all of my exponents positive, and then I can simplify from there. I have one negative exponent, and it's that 5 to the negative 9th power. I'm only going to move my powers that have negative exponents. So if I want to make that negative 9 a positive 9, I need to move that whole power to the denominator of my fraction. So now I have 5 to the 7th over 5 to the positive 9. And now this looks more like the problems that we've been doing. If I have 7 5's being multiplied in the numerator, 9 5's being multiplied in the denominator, how many are going to cancel out? Okay. How many will cancel out? 7 of them are going to cancel out. How many am I left with? 2. And where are they at? Denominator. Okay, so I have 1 over 5 squared. And what is 5 squared?
25.
1 over 25. Okay, that's one way. They're both pretty easy. I don't think one is easier than the other. The other way is if I look at my original problem, 5 to the 7th times 5 to the negative 9th, I'm multiplying powers. So I have the product of powers. And they have the same base. I have 5 as a base. If you are multiplying powers with the same base, what do you do with their exponents? Add them, right? You add them. So if I add my exponents, 7 plus negative 9 gives me negative 2. So now I have 5 to the negative 2nd. And if I want to make that negative 2 a positive 2, I'm going to flip it over my fraction bar. And you still get 1 over 25. And like I said, you choose what way you think is easier. They both will work. Okay, for this next one, if I have 12 to the negative 1st to the negative 2nd. We have thrown so many exponent properties at you. So whenever you look at a problem, you really have to decide which property applies to this problem. In this case, I have a power, this 12 to the negative 1st, that's a power, to a power, right? I have a power to a power. If I have a power to a power, what do I do with those exponents? Multiply. That's where you multiply. So what is negative 1 times a negative 2? A positive 2. So now I have 12 to a positive 2. What is 12 squared? 144. The hardest part is really figuring out what property that you need to use and then applying it correctly.
So do you multiply the exponents first?
Yes. The other option is trickier, I promise. So this is the easier option for this one. I'm not even going to show you the other way because it gets confusing. Okay, for this next one, if I have 5 to the 0 times 2, we're going to raise that whole thing to the negative 2nd power. And then in the denominator, I have 2 to the negative 2nd power. Okay, couple different places you can start. Let's say I want to start with my order of operations. Okay, order of operations tells me to do what first? Parentheses. Says I need to do parentheses first. So if I look inside that set of parentheses, is there anything I can simplify?
The 5 zeros.
What is 5 to the 0 power? 1. So now I have 1 times 2. Well, what is 1 times 2? 2. It's just 2. So now I have 2 to the negative second power over 2 to the negative second power. What do you notice about 2 to the negative second power over 2 to the negative second power? It's the same thing. What happens if you divide the same thing over the same thing? Equals 1. Now, if you wanted to, you could go through and make your exponents positive. So if I wanted to make this a positive exponent, I would move it to the denominator. And if I wanted to make that a positive exponent, I'd move it to the numerator. You still have 2 squared over 2 squared. Everything still divides out.
Can you take it from the bottom to the top and it still makes it a bottom?
So if I wanted to just move this up to the top and have 2 to the negative second times 2 squared. Is that what you're saying?
It's like.
Yep. Okay. Okay, next one. If I have 4 times 3, and we're going to raise that product to the negative second power. First way we could solve this one, think about your order of operations. What are you supposed to do first? Parentheses. So I need to take 4 times 3 first. So now I have 12 to the negative second power. If I want to make that negative to a positive 2, what do I do? Flip it to the denominator. So now I have 1 over 12 squared, or 1 over 144.
You said 144.
1 over 144, right? Is 144 and 1 over 144 the same thing? No. Would you rather have $144 or 1 over $144? I'd rather have $144. Okay. What if this time looks really similar, but what if I leave off the parentheses? So this time I have 4 times 3 to the negative second power. These are the ones where you have to be really careful because I do have a negative exponent. What is being raised to my negative exponent? Just the 3. So I am only going to move that 3. That 4 has no negative exponent. If it doesn't have a negative exponent, it's not going to move anywhere. The only thing I'm moving is that 3 to the negative second power, and when I move it to the denominator, it turns into a positive 2. And your answer should be 4 over 9. Okay, 2 more. Okay, if I have 3 to the negative first times 3 squared, and we're going to raise that whole thing to the negative first power. Once again, a couple different ways you can do this. If you notice that you have a power of a product, so I'm multiplying 2 things and raising it to a power, I could take each one of these things to the negative first power, but inside my set of parentheses, I'm multiplying powers. Do I have the same base? Yeah? Every class. So I'm multiplying powers with the same base. If you're multiplying powers with the same base, what do you do with their exponents? Add them. Okay, well, if I do that, it's going to be a lot easier than doing it the other way. So if I add my exponents, I get 3 to what power? Okay, 3 to the first, which we don't usually write. So I just have 3, and we're going to raise that to the negative first power. How am I going to make that negative 1 a positive 1?
Put it in the denominator.
Flip it to the denominator. So you should end up with 1 over 3. Last one. Okay, if I have 2/3, and we're going to raise the whole thing to the negative third power. This is where that second toolkit entry that I talked about comes in. I have a fraction that I'm raising to a power. If you have a fraction raised to a power, you have to give that power to the numerator and to the denominator. So you have to take 2 to the negative third power and 3 to the negative third power. How am I going to make those exponents positive? Right, I'm going to have to flip both of them. So that 2 is going to move to the denominator. The 3 is going to move to the numerator. So I have 3 cubed over 2 cubed. which is 27 over 8.